Hi everyone, my name is Julien Anet and I'm lecturer and research group leader at the Zürich University of Applied Sciences. And in the next few minutes I will be presenting together with my colleagues Julien Anet and Stefan Flug what the main activities are in micrometeorology of our research group. So we're very happy to be able to join this cost action, and I think that with those 4 different activities we can bring in a few inputs which may be useful for the community. So Cordine will talk later on about the first point. So we've been experiencing building and designing up rather large networks which are measuring relative humidity and temperature. So we had a large project running in the city of Zurich, and now currently also have a second project which is being initiated in the city of Winterthur. Then together with this design of the relatively large network, we've gathered some experience in designing own temperature measurement stations which are low cost and which are relatively precise. Then we've been dealing with a radiation correction algorithm, because what we realize is that the relatively low cost stations which you can buy nowadays have sometimes a very large radiation error, especially on hot days, and that is to be accounted for. And last but not least, I think we can bring in also some knowledge because we are trying to bridge the gap between measurements and also modeling. So Stefan Flug is specialized in modeling urban areas with large eddy simulations, and that is what he will also be talking about.
Hi, I'm Julien Anet and I'm part of Working Group 1. Reason for this is that I established the Urban Climate Network myself in Zurich about 3 years ago, a network with approximately 270 stations, and we use 2 different measuring stations for this. The project will be finished this year, but so far it looks good that at least part of the network will be taken over by the city of Zurich, thus ensuring the continuity of the measurements and also the data. As I mentioned before, we use 2 different station types. One is a commercially available station from Pessl Instruments called Lorraine, which you can see on the left-hand side, and on the right-hand side you can see the other station we use. That's a self-built radiation shield based on a model from the colleagues of Bern, which we equipped with a Sensirion smart gadget to record temperature and humidity. The station on the right-hand side is about 10 times cheaper than commercially available station and performs even better in some areas. The downside is you have to go on site to collect the data.
So as Cordine said, we have built up this station network in Zurich with more than 250 stations, and we had mainly these 2 types. So we had the Pessl Lorraine. To mention it, it was the old version, so Pessl has improved the design since then quite significantly. And then there was the own design and own built station type, which we were inspired for by Moritz Kubler from the University of Bern. And what you can see here is that we had actually more than 1 year of parallel measurements of 8 different stations, so 4 of each type. And they were oriented towards the north, south, west, and east. And what you see in the picture to the right is that they all deviate quite significantly on very hot days from the reference station, which was a Luft WS800 UME temperature station. And especially the Pessl Lorraines had up to 6 degrees of radiation error. And this is to be accounted for, because otherwise the measurements which you take in urban environments are extremely falsified. So we try to come up with different algorithms in order to correct that. And first of all, to develop an algorithm, you of course need to be sure what is important, what is influencing the radiation error. And of course there is the natural ventilation, which is important, so the wind speed is going to be a factor, and then there is of course the sun elevation angle, which is going to be important, and last but not least the amount of incoming diffuse and also direct shortwave radiation. But that's not all. Of course, you need to know when your station is exposed to the sun and when the station is not exposed to the sun, so when it is in the shadow. And for that, we have looked at two different algorithms. So one algorithm is directly done within QGIS. So there is the so-called UMAP plugin, which we applied onto three-dimensional information about terrain and the building height. And with that, we calculated an entire data stream for all information for all stations in Zurich, so that we know in a resolution of 15 minutes over an entire year when a station is, at least in the GIS model, in the sun when it's in the shadow. Unfortunately, because the calculations are very costly in terms of computational performance, we had to limit ourselves to a resolution of 5 meters. Therefore, single trees or also light poles are not included in that model. And that is clearly a disadvantage, especially when you have large light poles like you see here to the left. And that is then the second try, the second version of the algorithm, where we went out and took pictures, hemispheric pictures with a 360 degrees camera, GoPro camera, and by applying different image processing algorithms, we generated a binary image of it, where everything which is white is a direct view of the station into the sky, and everything which is black is an obstructed view into the sky. And with that, you're basically unlimited in temporal resolution, so you can even have a 1-minute temporal resolution of an entire year if the station is directly exposed to the sun or not. And as you can see on the right, this algorithm is relatively successfully able to correct the radiation error. So in black we have the reference, in red you see the uncorrected temperature measurement from a Pessel-Lorraine station, and in green you see the result after the temperature correction, which is based on the information of the hemispheric image and a few meteorological reference measurements done in the city of Zurich.
Hello, also from my side. I am Stefan Fluck and I am entered in the working group 2. And as you can see on the slide, our group is also basically in the business of modeling urban climate, and I'm the responsible person to do high-resolution urban climate simulation. For that, we are basically using the PALM modeling system, and we use that to simulate temperatures and heat stress in cities. And we are also very interested in katabatic airflows and how they penetrate into the city. We use the measurements that my colleagues described before as an example to validate our results, as you can see on the top right of the slide. And so from our side, from the modeling perspective, we really see the importance of having good data sets. So to summarize, I guess we can say that in our group, we have experience in establishing, operating and maintaining micrometeorological monitoring networks. That's basically where Kurdin can contribute in working group 1. Also, we have, as it says here, competences in data processing and handling of data constraints. For instance, the radiation corrections, where Julien can contribute in working group 3, and I can also do something in working group 2. And finally, basically, we have a sense of how modeling and measurements can be combined. So that's where I see I can contribute in working group 2. So that's us, and we are looking forward to meeting you. Thank you.